Welcome to Section 4.3, a right angle theorem. Our objective is to apply one way of proving that two angles are right angles. In class, we're going to work on page 182 to 183, 1 through 15 the odds, but we're going to skip number 13. Number 13 is a case of the missing diagram, so if you're dying to get a little extra practice, have at it. Okay, so for our first theorem, if two angles are both supplementary and congruent, then they're right angles. Well, let's draw it out and see what happens here. First and foremost, if they're supplementary, we know they're going to be on the same line. Now, if they're both congruent and supplementary, we're going to call them both x. Now, if we have 2x equals 180 because they're supplementary, divide both sides by 2, each one of them is going to be 90 degrees, meaning that each one of these is going to be a right angle. Okay, here we go. Here's our first proof. So let's start off with our statement and results. So, we're given that AB is congruent to AC and that BD is congruent to CD. Let's put in those tick marks. AB, AC, BD, DC. Those are all given to us. Now, let's look real quick at what we're trying to prove. We're trying to prove that we have an altitude. And if it's an altitude, then it's going to be a perpendicular segment from the vertex to the side opposite. So here we go. Looking at my picture, I see that I have reflexive. Now, remember, if you get the urge to draw it, have that same urge to write it. AD is congruent to AD. The reason? Reflexive. Now let's say our triangles are congruent. Triangle ABD is congruent to triangle ACD. The reason? Side, side, side. Now, altitudes go with perpendicular. Perpendicular goes with right angles. We want to show that we have right angles formed in here. Well, let's use that last theorem that we just learned and start off with our CPCTC, saying that our angles are congruent. Angle ADB is congruent to angle ADC by CPCTC. Put that in there first. Now let's talk about them being supplementary. Angle ADB is supplementary to angle ADC. If two angles form a straight angle, they are supplementary. Okay. Next, let's say angle ADB and angle ADC are right angles. If two angles are supplementary and congruent, they are right. Let's go ahead and put our right angle tick marks in there. Now, if we have right angles are formed, we can automatically skip right into our altitude. We can say that AD is an altitude. For our reason, if a segment from a vertex forms a right angle with the side opposite, it's an altitude. Alright, there's that. So here's how that theorem is actually going to be applied. It's going to be applied by helping us show that we have altitudes. Alright, here we go. So we have our last proof. Now, I want you to take some time and try this proof. What we're trying to prove at the end is that AC is going to be the perpendicular bisector. So we're trying to prove two things are happening at once. If that last step gets you stuck, no biggie. We definitely want to prove perpendicular and bisector in separate steps and then combine them. Push pause and let's see what you can come up with. Okay, so here we go. I took the liberty of writing down our givens and marking up our picture. Now, if we're trying to prove that in the intersection there's a perpendicular bisector, I know I'm either going to be working with this left two triangles or these right two triangles. And what I see I have markings for is going to be these big triangles. So if you're thinking detour, you're correct. So here we go. For my next step, I'm going to say that AC is congruent to AC bireflexive. And put in my markings, which are difficult, so I'm just going to do a little squiggle line here. And then for my next step, I'm going to prove those big triangles are congruent. Triangle ABC is congruent to triangle ADC by side, side, side. Again, I either want these left two or these right two, and I'm going to work off my right two. It wouldn't make a difference except that I don't have so much room to work on the left side. So here we go. For my CPCTC step, I'm going to end up proving angle BCA is congruent to angle DCA by CPCTC, which would be these angles right here. Now I have two options, either reflexive here, or I should notice that these big right triangles stem from isosceles. If sides, then angles. It doesn't make a difference, but that's what I'm going to use. I'm going to do angle CBD is congruent to angle CDB by if sides, then angles. I'm going to mark them in. Now, my next step is I'm going to prove these little triangles are congruent. Triangle CBE is congruent to triangle CDE by angle side angle. If you did reflexive, instead you'd have side angle side. Next, I'm going to say angle BEC is congruent to angle DEC by CPCTC, which is going to be these angles right here are congruent. And I notice that they're on the same line. So I'm going to say angle BEC is supplementary to angle DEC. If two angles form a straight angle, they are supplementary. Now, I'm trying to prove the perpendicular part. So let's go ahead and state my right angles. Angle BEC and angle DEC are right angles. If two angles are congruent and supplementary, they are right. Okay, I'm going to bring it up for my next step. So here we go. Continuing my proofs, we got a lot of steps here. What I'm going to end up saying now is that I have my perpendicular lines. I'm going to say AC is perpendicular to BD. If lines intersect to form right angles, they are perpendicular. So there's my perpendicular part. Next CPCTC I'm going to show is going to be that BE is congruent to ED CPCTC. My next step is to show that I have the bisector. I'm going to say that AC bisects BD. If a segment divides a segment into two congruent segments, it bisects. Now, next, we got perpendicular, we got bisector, we got to combine them. Here we go. Last step. AC is the perpendicular bisector of BD. If a line is perpendicular and bisects, it's the perpendicular bisector of a segment. and that's it. So all together, let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14-step proof. Not a lot of fun, but I hope you got it. Okay, so here's the answers to the homework that we're going to have from tomorrow. If you notice here, a lot of these proofs have a lot of steps to them. Got a 10-step, a 10-step, a 13-step, and a 9-step. So we're talking some kind of lengthy proofs here, some of which may be detours. Take your time, make sure you ask some questions tomorrow if you have them, and let's see what we can do. Have a good one.